In this video, we're going to talk about the distance formula and do a couple examples where we find the distance between 2 points. Let's start off with how do we get the distance formula? So here we have a right triangle that's labeled with legs A, B, and a hypotenuse of C. So we can use Pythagorean's theorem here, and we're going to find that we have an A value, which is one of our legs, so our A squared, plus our B squared equals our hypotenuse squared. And so that's Pythagorean's theorem. So if we look to the triangle on the right that looks like it's been graphed on a coordinate plane, we can see that this distance between our y values is the absolute distance between those two values, because distance can't be negative, or the length of a triangle cannot be negative. So really, this is kind of like saying that that's our A side. And here, between our x1 and our x2, that distance is the absolute value between the x2 and the x1. This is going to be our B value, or our other leg. And then finally, this hypotenuse is our C. So we can rewrite these. So if we go ahead and we plug y2 minus y1, now sometimes that's known as the change of y. And for our A value, so y2 minus y1 quantity squared plus our x2 minus our x1 quantity squared, and sometimes that's known as the change of x. And that's going to equal our c squared. So if I want to know what is the value of just c, what is the distance of just c, then I would need to square root both sides so I can get that c by itself, which would give me c equals the square root of y2 minus y1 quantity squared plus x2 minus x1 quantity squared. And we can even rewrite that using our change of x and change of y. So we could say that c equals the square root of the change of y squared plus our change of x squared. Either of those is fine. And these are our distance formula. So why don't we practice using those? Now the distance formula won't only find the distance between 2 points, but another use that it has is that it can be used to verify that a triangle is a right triangle. If we find the distances of each of the sides and plug it into Pythagorean's theorem, then we know that that's a right triangle. So let's practice finding the distance between 2 points. So here we have 2 points, 3, 1, and -1, 3. So remember that our distance formula is the square root of the change of y's quantity squared plus the change of x's quantity squared. So if we look at our values, here we have our x1, and here we have our x2. Here we have our y1, and here we have our y2. So let's go ahead and let's plug that in to our values to see what we've got. So we've got 0 minus 1 quantity squared plus -3 minus 3 quantity squared. So now we have 0 minus 1, which is -1, and we'll square that. And then -3 and -3 is a -6, and we'll square that. And so now we're going to go ahead and we're going to plug in -1 squared plus 6 squared into our calculator, and then put that number right there. So we should get that our distance is the square root of 36. 7. And the square root of 37 does not reduce, and so that is our final answer. And we're done.